Hi, I'm Ed Moschetti from Control Specialties. Let's take a few minutes and talk about one of the principal causes for failures in centrifugal pumps, cavitation. Cavitation is caused when water boils inside the pump. At sea level, water boils at 212 degrees Fahrenheit. As we move to higher elevations, the temperature of the boiling point of water will decrease. If we take a look at a typical pump curve, on the vertical axis, we've got the pump head, which can either be in feet or pounds of pressure or pounds per square inch of discharge pressure. And then we've got the pump flow. And then we've got sort of an upside down curve which describes the capabilities of that particular pump. So as we go to the point where we shut off the discharge valve on the pump, we go to shut off head, no flow. And as we open the pump all the way to its widest point, we go to a point called open flow. And those 2 points, as described by this curve, become the characteristics of the pump. The other issue that works in conjunction with this curve is the amount of static head pressure which has to be on the inlet side of that pump to prevent the water from inside the pump from boiling. And that pump curve is called NPSH, or net positive suction head. And what net positive suction head does for us is essentially puts an artificial pressure on the inlet side of the pump to depress the boiling point of the water so it won't boil inside the pump. Notice that this NPSH curve remains relatively flat through about 75% of the pump performance curve and then begins to rise up. If we've got a pump installed in a situation where there's insufficient NPSH, then the water inside the pump will boil, which will quickly destroy the seals and eventually all the other moving parts of the pump. This is a typical cross-section of a Grundfos multi-stage centrifugal pump. The pump can itself, or stack kit, is actually made up of a series of individual impellers, and it can be anywhere from 1 to as many as 15 to 20, depending upon the volume of water we want to pump and the pressure that we want to meet it at. It's inside this area on the bottom side of the pump where the cavitation will occur, and when that happens, typically the bottom seal will be attacked and eventually get up to the top seal and destroy the pump. Cavitation can destroy a pump in literally less than 1 minute. To properly set up a pump, we make provision in the discharge piping of the pump to allow us to take some precise pressure measurements so that we can set this pump up on the curve at the discharge pressure, which stays within our NPSH requirements. The piping arrangement of the pump on the downstream side should include the following principal items: a pressure gauge which is located on the discharge side of the pump, then a globe valve so that we can throttle, a gate valve so we can isolate the pump when we want to do repairs on it, a check valve to prevent backflow into the pump, and then a second pressure gauge to confirm that the pump is in fact meeting the requirements of the system to move the water that we're pumping away from it. In setting the pump up into operation, we need to know what discharge pressure we need to be at to put ourselves in the curve. So let's say, for the sake of argument, we need to be at a discharge pressure of 60 pounds. What we do is start the pump up and adjust the globe valve until we see this pressure gauge is at 60 pounds, and from the curve we know that pump is then pumping a specific flow rate in gallons per minute of water that we want to meet a requirement. Once you've made that setting, you may want to then take an amp probe and verify that the motor current going into the pump is within the range of the motor. We then take this valve and either remove the valve handle or put a warning tag on here which says, please do not adjust this valve, this is for setup of the pump. Then if we have a situation where later on we've got to do repairs in the pump, we don't want to tamper with this valve, we just simply open and close our gate valve to isolate the pump, do repairs on it. If you just take this simple precaution to park the pump on the curve and keep the NPSH within a proper range, you'll solve yourself a lot of headaches. Thank you for listening.